Okay, question 14, 2023. So I'm just trying to come to terms with what we have. So I'm going to reconstruct it. So we have a larger triangle, and then within the larger triangle we have part of it, but not only any part of it, it's half this hypotenuse here, halfway down, coming out here like this. Now, even though I'm not doing anything new, by drawing it myself, I'm giving myself a chance to become familiar with it. Okay, and the tricky thing about this is it isn't just cut straight down here. This right angle is going up at a different angle. Now, you'd be kind of blinkered into going with similar triangles only. But I want to focus your attention on this small triangle here and ask, is it a right angle triangle? Yes. Do we have two sides? Yes. So Pythagoras is waiting for us to use it to find x. So let's go ahead and do that. So x is a leg and not a hypotenuse, so there'll be a minus involved. So taking, if you just want to redraw your equation from the log tables, page 16, you have the hypotenuse is c, and you have a and b. So we need a bit of rearranging to get x. So what happens is x is equal to the square root of the long side, 15 squared, minus the shorter side, squared, like that. So that's hypotenuse for a leg. And it's 12 because it's a scaled up version of 3, 4, 5. Okay, now we have 12 here and we have 12 here. So now we can focus on the larger triangle. We have 24 because x and x, 12 and 12. We have y. Quite a tricky question, I have to say. It's the second time during this exam paper I've been sort of impressed with the level of challenge. You know, this is a nice challenge. Okay, so what we're going to use is we're going to use this angle here. And we're going to notice that we do have a ratio here. We have opposite and hypotenuse. We know what the sine of this angle is. Okay, 9 over 15, and correspondingly, and just do that again, opposite over hypotenuse. Now on the bigger triangle, opposite is y and hypotenuse is 24. So we have inroads, we have a solution. We can use the sine of that angle, even though I don't need to mention it. I can say 9 over 15 is the same as, and this is the similar triangle identity. So 9 over 15 is the same as y over 24. And then it's just going to walk out for us. We'll clear the fractions by multiplying up to 24 and leave the 15 where it is, because it's not doing any harm there. So we have 24 times 9 over 15, which of course simplifies, but we'll let the calculator do that. Get 72 over 5. Using similar triangles, work out the value of y. We have used similar triangles. Okay, we've used the corresponding sides. We've got 14.4. Looking for units somewhere. Are there any centimeters in there? There aren't, so just you can use the letter U for the unknown unit. So this to some sort of scale. Let's say x equals 12. how are we doing? Let's grade ourselves. And yeah, let's grade ourselves. Let's see how we got on. So did we get x equals 12? We did. Did we get y equals 14.4? We did. And you'll see, yeah, they replaced the 2x and they used a similar triangles. Okay, been a long paper, longer than I thought. Got there in the end. We'll go to 2022 paper next. See you in the next one.